To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all part B of paper 2 of the G.C.E O-Level 2021 paper with you all. In the previous chapter, I discussed the part A questions with you all. Those questions have to be answered on the space provided to you. But here, there are questions. If you read the instructions, you all know, and answer only 3 questions from the questions number 5, 6, 7, 8 and 9. So, here there are 5 questions. After that, you need to only answer 3 questions. So, there are 5 questions. Now, 5 questions, each question is out of 20 marks and they can have a part A, part B, sometimes part C, sometimes part D also. And these questions, there will be one question related to biology lessons, one related to chemistry, the other one related to physics. And the last 2 questions, they will be a combination of different lessons. Maybe biology, chemistry and physics, or biology, physics, chemistry, physics, or biology, chemistry. So, like that, you will get different questions. You have to read through all the questions, select the most suitable one for you all. The one you can answer well, and then accordingly prioritize them and answer the questions in the booklet provided to you. So, here of course, I will be writing the answers here. Now, if we look at the 5th question, A part of part B, respiration is a biological process that you know. The system organized for it is called the respiratory system. So, you all know students, when we say respiration, it is a biological process. It is a characteristic of living organism, an important characteristic, important biological process, and that is carried out by the respiratory system. This particular respiration occurs in 3 steps. You all know it is the first step is the gas exchange between the environment or the atmosphere and the lungs. Then the second step where there is gas exchange between the lungs and blood vessels. And the third one is the cellular respiration. So all the process together is the function of the respiratory system. And this respiratory system begins with the nose, where you have the nostrils, they are the opening. Then we have the nasal cavity. Nasal cavity opens into the pharynx. Then you have the larynx. Larynx then opens into the tubular structure called the trachea. Then trachea branches out into 2 bronchi or bronchus. Bronchi plural, bronchus is the 2 tubes. Then the bronchus branches out into bronchioles. And finally, the bronchioles end up in the small sacs called the alveoli or the alveolar sacs. All these, the bronchus, bronchioles and the alveolar sacs, part of the bronchus actually, they are all present between the lungs. There are 2 lungs, the right lung and the left lung. So, there is gas exchange taking place inside with the atmosphere as well as from the air inside the lung and between the blood vessels, the blood flow. So, there are 2 types of gas exchanges take place. You all are familiar with that process. And for this to happen efficiently, the gas exchange to happen efficiently, there are many adaptations of the respiratory surface, which is the alveoli, the alveolar wall actually. That is the respiratory surface or the gas exchange surface. So, you are familiar with the adaptations. Now, if we look at the questions. First one, write 2 changes occurring in inhaled air when it passes through the nasal cavity of man. Now, when it passes through the nasal cavity, you all know students, normally the atmospheric air does have a certain amount of humidity, but that is not enough for the proper transport of air into the respiratory system. So, because of that, within the nasal cavity, the air is humidified. Humidification of air. That happens. So, in the nasal cavity, you all know there are the cilia, that actually prevent the dust particles and other external material from entering into the respiratory tract. So that is another function. And the humidification occurs by the mucus. There is mucus. So there is humidification, and addition to that, all these dust particles, the pathogens, they are retained or they stick to the mucus. With the movement or the function of the cilia, these particles are released out back into the environment. Sometimes that is why when you go to a dusty place or if you touch something that is very dusty, you sneeze. So when sneezing, the dust particles and everything is given out of the respiratory system so that they don't enter the respiratory tract. Is that clear? So two things I have told you all. One is the humidification of air, then removal of foreign matter and dust particles. Then there is the other one. Now if you take the environment temperature, that temperature is different from the body temperature. So there what has to happen is this particular inhaled air has to be brought up to the body temperature. So that also happens in the nasal cavity. So there are 3 changes. I will write all 3 of them. You only need to write 2 because here you can see the question, write 2 changes occurring in inhaled air when it passes through the nasal cavity. So 1, air is humidified. Then the next one, it is converted to body temperature. And the third one, foreign particles or dust is removed from inhaled air. So there are 3 changes. You need to write only 2. Now just because it is a question where you write the answer in a booklet provided, you don't need to write in very much detail, or it doesn't have to be a long answer. Even for this, you can write it short like that. Humidifying of air or humidification of air, then converted to the body temperature, and also the foreign particles or dust is removed from inhaled air. So those are the changes taking place. Then the second one, name the 2 structures. So here also you have to look at the number. 2 structures which contain muscles contributing to increase the volume of the thoracic cavity during inspiration. So you know the lungs are contained in the thoracic cavity and they are actually covered by the rib cage. Rib cage means the ribs, the 12 pairs of ribs as well as the sternum. Ribs connect from the backbone or the vertebral column to the front part. So they make the rib cage, and the sternum is also part of the rib cage. Attached to the rib cage, you have the intercostal muscles. Now what happens during inhaling process? The intercostal muscles contract. When the intercostal muscles contract, the rib cage moves up, sternum moves forward. At the same time, there is the diaphragm that separates the thoracic cavity from the abdominal cavity. The curvature of the diaphragm also reduces due to the contraction of the diaphragm. So because of that, the volume of the thoracic cavity increases. When volume increases, the pressure inside the lungs decreases. Due to that, the air flows into the lungs. At the same time, when you exhale, the opposite happens. The intercostal muscles relax. Because of that, the ribs and the sternum, they go back to their initial position. At the same time, the diaphragm relaxes. Because of that, the curvature of the diaphragm increases. So then what happens? The thoracic cavity, the volume decreases. Due to that, the pressure increases, and because of that, the air is exhaled out. So the two structures, what are the two structures? One is the rib cage, the other one is the diaphragm. They both involve in both inhaling and exhaling process. Although they have asked the question as two structures which contain muscles, that is the intercostal muscles, contributing to increase the volume of the thoracic cavity during inspiration, rib cage and the diaphragm. You have to write both. Rib cage and diaphragm. Those are the two structures. You can just write rib cage and diaphragm. That's it. So here you don't have to explain anything, only write the structures. But I have explained the process to you. So with that, I'll move to the next part. Here we have part 3. Another diagram is given to you. A sketch of an alveolus. Now I told you all about the alveolar sacs. Alveolus, alveoli, all refer to the same thing. So a sketch of an alveolus in which gas exchange takes place in the respiration of man is given below. So in the alveolus, it is the gas exchange. Indicated as X and Y in the figure are two types of gases. The gases are indicated as X and Y that exchange in the alveolus. So if you look at the alveolus, this is the alveolus. You can see here, this structure is the alveolus. And around that, the alveolar wall is very thin. Around that, there are a lot of capillaries. It is highly vascularized, so that there will be efficient gas exchange. So there is the blood capillary you can see. So the inhaled air, when you inhale, comes into the lungs and finally they reach the alveolus. So here you can see the air coming in that they have marked X. So you know the inhaled air is rich in or has a high amount of oxygen. That is what will be exchanged into blood. Oxygen will diffuse into blood. So X has to be oxygen. And then you can remember with blood, there is both carbon dioxide and water vapor that is there as excretory materials in the exhaled air. So both are there in this blood vessel, blood capillary. They are high in carbon dioxide as well as there is water content. So that diffuses, the carbon dioxide diffuses into alveolus. So here Y has to be carbon dioxide and water. Both diffuse into the alveolar sac. So that can be released with the exhaled air. Is that clear? So that is the information that you can get from here. So A is the inflow of blood. Now here you can see the hemoglobin. Oxygen is attached to the hemoglobin. Red blood cells has the hemoglobin. So these are the red blood cells. You can see biconcave disc-like structures. So they transport oxygen. So when blood flows out, here the blood will have more carbon dioxide, less oxygen. Here more carbon dioxide, less oxygen. Here it will be no or very less carbon dioxide and high amount of oxygen. That's why we call it as deoxygenated blood and oxygenated blood. You all know when there is circulation from the pulmonary arteries, take the deoxygenated blood to the lungs and there gas exchange occurs, and then the pulmonary veins bring back the oxygenated blood back to the heart. So here the blood that comes in is the deoxygenated blood. That is the oxygenated blood. You can remember that. An efficient gas exchange takes place. Oxygen is given to blood, carbon dioxide and water vapor are given back to the air which is exhaled out. Is that clear? So this is the gas exchange surface, respiratory surface of humans. You can remember that also. So based on that, if we answer the questions, Here you can see A, name gas X and gas Y in respective order. So here you can either give as X, oxygen, or you can write it as O2 or O2 gas, oxygen gas. And Y, it has to be CO2 or carbon dioxide. You can give H2O gas, that is water vapor. So both can be given. Mainly it is carbon dioxide since they have asked as a gas, but since water also is in the vapor stage, that also will be there in the exhale there. You can remember that. Then B part, by what process does gas exchange occur between alveoli and blood capillaries? So when I explained it, I told you all they diffuse out. So the process is diffusion because the amount of oxygen inside the alveoli is very high and the alveolar wall, capillary wall, they are very thin. Easily oxygen can diffuse into bloodstream. The same way carbon dioxide concentration is high in the bloodstream capillaries. So therefore, carbon dioxide can easily diffuse back into the alveolar sac. So it is diffusion. Here the answer is going to be diffusion. So here also they have asked you to write it in respective order. So you can write it as oxygen, then carbon dioxide, or you can write it as X and Y. What are the gases? So you have to be very specific when you answer the question. You don't have to write long sentences, but you have to write the correct point, the required point, and you have to be very specific. Is that clear, students? So with that, I'll move on to the next part. Part 3, again the diagram and the introduction is given to you. Part C of that, what is the main difference between the blood that enters the capillary at A and the blood that leaves the capillary at B? Already I explained that to you all. The blood that enters A has high carbon dioxide, very less oxygen concentration. Whereas what leaves B will have high amount of oxygen and less amount of carbon dioxide. So that is what you need to write. Mainly because we call it as oxygenated and deoxygenated blood, you have to give the answer in relation to oxygen amount, oxygen content. So here you can say A contains, or here we can say blood contains less oxygen. Here B, blood contains high amount of oxygen. If you write that, that is correct. So A, less oxygen, B, more oxygen. Is that clear, students? So with that, the next part of the question. Again, the introduction and the diagram is given. Part D, state an adaptation of alveoli to make the gas exchange efficient. A very efficient gas exchange. Alveolar surface is the respiratory surface here. Gas exchange occurs through that. So what are the adaptations? The alveolar wall is very thin, or the alveolar surface is very thin. That is one. What is the other one? For efficient gas exchange, the diffusion, it is better if it is moist, so that the gases can dissolve with the moisture and easily diffuse. So the surface is always moist. How does that happen? There is mucus that keeps the surface moist. Then the other thing is, there is large number of alveoli. You can remember it is like the bunch of grapes where you have the bronchioles. They divide into small branches, and at the end of the branches there are very small sacs. So there is large number of alveoli. Because of that, the surface area is very high. And also around the alveolar sacs, there is a lot of blood capillaries. So highly vascularized so that there will be efficient gas exchange. There are 4 adaptations. You can write one adaptation out of that. So here write state an adaptation. So you need to write only one. But I am going to write all the possible adaptations. So here we can say alveolar surface is very thin, or you can say alveoli has a very thin wall. We can say alveoli or alveolar surface is, so we can say alveolar surface is moist. Then it is highly vascularized. Or you can say there is large number of capillaries around alveoli and a large number of alveoli are present. So here students, like I told you all, I have written all the possible adaptations. You have to write only one adaptation, state an adaptation. So alveolar surface is very thin, or alveolar has a very thin wall. Alveolar surface is moist. It is highly vascularized, or there is a large number of capillaries around alveoli and a large number of alveoli are present. Any one of the adaptations. So with that, I'll move on to the next part. Here the same question, the same diagram and the introduction. E part, by what name is the ailing condition of gradual destruction of alveoli due to accumulation of compounds based on silica is in alveoli known? Now there are certain industries that use silicon, where there is silica dust. When the silica dust is inhaled, they actually cause a defect or destruct the alveoli. This condition is known as silicosis. You can remember that. Silicosis. So that is what they have asked. By what name is the ailing condition of gradual destruction of alveoli due to accumulation of compounds based on silica in alveoli known as? That is silicosis. Similar to this, there is asbestosis also. Asbestos sheet, the small particles, if they enter the alveolar sacs, the lungs, they cause asbestosis. This is silicosis. So you can remember that. So with that, I'll move on to the next part of the question. This is part B. So in part A, it was related to respiratory system. Now part B, the process of producing food in green plants is called photosynthesis. So you're familiar with photosynthesis. In green plants, there is chlorophyll in chloroplast, so that is the organelle. There photosynthesis occurs. You all know there should be sunlight, water, carbon dioxide, all those are external factors. In the presence of chlorophyll, that is an internal factor. Synthesis of food is what we call as photosynthesis. Out of that, Both carbon dioxide and water are the raw materials. Glucose and oxygen are produced. Now, glucose is the main product. Oxygen is the byproduct of photosynthesis. And during photosynthesis, the sunlight, the solar energy is converted to food. That is chemical energy. So, the solar energy or light energy is converted to chemical energy. That is, the sunlight is fixed as food, that is glucose. So, you all remember glucose is temporarily stored as starch in leaves and then it is transported in the form of sucrose. So, that is how photosynthesis occurs. So, the question related to that. First part, write the energy transformation occurring in the process of photosynthesis. What I just mentioned, it is light energy to chemical energy. Light energy to chemical energy. Light energy to chemical energy. Then the second one, state how atmospheric carbon dioxide necessary for photosynthesis enters plant leaves. Now you can remember, students, if you take the structure of a plant leaf, you have the epidermis around that. Above that you have the cuticle, then you have the epidermis cells there, then you have the mesophyll cells, the parenchyma, palisade parenchyma and the spongy parenchyma, like that. If you take the epidermis, you can remember there are the guard cells like that in the epidermal cell. So, this guard cell, there is the stomata. You can remember. So, the stomata, in between here also you will have the stomata like that. The guard cells and the stomata. Stomata are the openings, they are pores. So, through that, the atmospheric air can diffuse into leaves. And there are intercellular spaces, they can diffuse through the intercellular spaces and they reach the mesophyll cells. You can remember that. So, here they have asked how atmospheric carbon dioxide necessary for photosynthesis enters plant leaves. So, there carbon dioxide diffuses through the stomata of leaves. So, you all know you have the upper epidermis and the lower epidermis. In both there are stomata. There are more stomata in the lower epidermis compared to the upper epidermis. And also in young plants where the stem has chlorophyll, chloroplast, there are stomata in the stem also. So, there are also photosynthesis can take place. So, it is mainly through the stomata of the leaf. So, here we can answer that as leaves because they have asked photosynthesis enters plant leaves. Is that clear, student? So, with that, I'll move on to the next part. Third part, it is not possible to show water is an essential factor for photosynthesis by a simple laboratory experiment. Do you agree with this statement? Give a reason to validate your answer. So, do you agree with the statement? Yes. Normally, we test for the different factors. Now, sunlight we can test carbon dioxide and also the requirement of chlorophyll. But water we can't test. What is the reason? When you do a test, to confirm that this factor is necessary, we need to have a control experiment. So, in the control experiment, we need to remove that factor. Now, if you remove the water from a plant, if all water is removed from the plant will wilt and die. So, because of that, we cannot carry out that experiment. But instead, you all know, students, they have the radioactive elements, isotopes of oxygen and hydrogen. There are radioactive isotopes. So, you can use the radioactive water molecule and using that, they can detect and they can observe how the reaction occurs. By doing that, you can confirm that water is an essential factor, but normally in the laboratory, it is not possible to show that. So here we agree with the statement. So you have to say yes, and then you have to give a reason to validate your answer. So there we can say, if water is removed completely from a plant in the control experiment, the plant will die. So that is the reason why we can't do this activity. Is that clear? So it is not possible to show water is an essential factor for photosynthesis by a simple laboratory experiment. You have to note that. Simple laboratory experiment like we do for other factors. But the one where I mentioned about the radioactive isotopes, that is a complicated, more tedious process. So that we can't do in our normal school laboratory. So here we agree with this statement and this is the reason. Is that clear, students? So with that, I'll move on to the next part. Part 4. The water essential for photosynthesis is absorbed by roots and transported to plant leaves through the xylem tissue. So there you all know, students, it is osmosis. When there are roots have root hairs in order to increase the surface area. The amount of water in soil is normally high compared to the roots because roots have a lot of ions in them. So because of that, water can easily go from the soil to the roots. They can be absorbed, but they have to travel through the membrane. So because of that, we call that process as osmosis. So by osmosis, water is absorbed. Then they get into the xylem of roots, xylem of stem, and then xylem of the plant, the veins, and then they diffuse into the parenchyma tissue. So that is how water is used for photosynthesis. A part of the question, of the cells that form the xylem tissue, what are the types of cells that contribute to transport of water? Now you all know xylem is a complex permanent tissue. Why do we call them complex permanent tissues? They are made up of more than one type of permanent cells. So there is the xylem vessels, which are made up of xylem vessel elements, then the tracheids, then there is xylem parenchyma and the xylem fibers. Out of these, only the xylem parenchyma is the living cells. All the others, vessel elements, the tracheids and the xylem fibers, they are all lignified cells. Because of that, they are all dead cells. So the xylem vessel elements combine and form the xylem vessel, where the cross walls are completely dissolved and it becomes a tube-like structure. Then there is the tracheid, as well as xylem parenchyma also contributes in transport of water. So you have to write all three cells there. Xylem vessel. Since they have asked, what are the types of cells? So xylem vessel elements, tracheids, and xylem parenchyma cells. So you have to write all three there. So those are the three cells. But the xylem fibers are there for support. So you cannot write that there. Then B part. In addition to water, name another substance that is transported through the xylem tissue. Now xylem, it is transportation of water and minerals. So minerals are also transported with water. That is what you have to write here. Minerals. Minerals. Is that okay, students? Minerals are transported with water. So with that, I'll move on to the next part. Here, part C. In addition to transport function, state the other function carried out by the xylem tissue. Now, we all know, like I mentioned, the xylem vessel elements, tracheids and xylem fibers, they are lignified cells. So, because of that, they are dead cells and they provide mechanical support to plants. Especially the herbaceous plants, they provide mechanical support, or the plants before the formation of wood. So, the next or the second function is the mechanical support. Provide mechanical support. Mechanical support. That is the answer. Then the last part of the question, here you can see D part. Describe briefly how the cells in the xylem tissue are adapted to fulfill the function you stated in C above. So, what is the adaptation? They are lignified cells, or you can say lignified cells. Lignified cells are present, or you can say there is lignin deposit in cell wall. So, either one answer is fine. That is the reason how they are able to provide this mechanical support. So, that is the last part of this question. So, here we had part A, part B. Each part had many other parts, and in total, as I have told you all before, each question, the total marks is 20. So, you will be answering 3 questions, each question out of 20. So, that will contain a total mark of 60. So, 60 for part B, 60 for part A. Total is 120. When that is divided, you get it out of 60. That will be added to part 1, that is out of 40. I have explained this to you all before also. So, with that, students, I will move on to the next question. That is question number 6. So, here we have question number 6 that also has A part and B part as well. So, here you can see sodium hydroxide. So, that is a chemistry related question. Question number 6 A part. Sodium hydroxide, that is NaOH, is a basic chemical compound. It acts as a strong base in an aqueous solution. So, here you have to note those terms, students. Basic chemical compound. It is a strong base. They have given the name and the chemical formula. So, you all know when we say bases or basic substances, when they dissolve, they release hydroxyl ions, OH minus ions. So, here NaOH, sodium is the positive ion, OH minus is released when it dissolves in water. So, in the aqueous solution, if they increase the concentration of OH minus ions, we call them as bases. And if they dissociate completely, then we call them as strong bases. If they dissociate partially, they are known as weak bases. So, you are familiar with all these concepts. And you know how we test and identify bases. Using the litmus paper, the red litmus becomes blue, or pH paper, usually pH is above 7. From 8 to 14 at 25 degrees Celsius is the basic pH. In addition to that, there are the indicators like phenolphthalein, methyl orange, which give color. Phenolphthalein gives pink color with bases. Methyl orange gives orange color with bases. So, like that also you can identify bases. There are bases in the laboratory like sodium hydroxide. At the same time, there are bases at home that is available, basic substances. So, you are familiar with all that. The first question, explain what is a base according to the way it behaves in an aqueous solution. What I just mentioned. Bases are chemical substances substances that increase the hydroxyl ion, or you can write it as OH minus ion. Concentration of an aqueous solution. Hydroxyl bases are chemical substances that increase the hydroxyl ion concentration of an aqueous solution. So you have to mention aqueous solution. When they dissolve in water, they form the aqueous solution. In that, they release in OH minus ion. So they increase the OH minus ion concentration. I'm sure you all can understand that. So with that, I'll move on to the next part. Then the second part of the question, why is sodium hydroxide called a strong base? That also I mentioned to you all, because it ionizes, or you can say dissociates, completely in aqueous solutions. So this is the answer you need to write. I'm just going to write the equation just for you all to recall what is there. If you have sodium hydroxide solid, if you dissolve it in water, H2O liquid, it completely ionizes and becomes Na plus aqueous and OH minus aqueous. So there you can see it increases the OH minus ion concentration. So it is a base, and because it completely ionizes and completely they become Na plus and OH minus, that is a strong base. Is that clear, students? You don't have to write this for the answer. This is the answer because it ionizes or dissociates completely in aqueous solution. Then, the third part of the question. So, name an industrial use of sodium hydroxide. What are the uses of sodium hydroxide? Now, we use it for the production of soap, production of paper, then silk, that is artificial silk, and also refining of petroleum products, even in the production of paints. So, those are the industrial uses of sodium hydroxide. So, we can say production of paper, soap, artificial silk, and paint. And it is used in refining of petroleum products. So, producing paper, soap, artificial silk and paint, and also refining of petroleum products. In addition to that, we use sodium hydroxide in laboratories. For different experiments as a base, as a chemical substance, it is used. So, here name an industrial use of sodium hydroxide. So, you need to write only one industrial use. Name an industrial use. I have written two here: production of paper, soap, artificial silk and paint, refining of petroleum products. You can write any one of the two answers. Is that clear, students? So, with that, I'll move on to the next part. Fourth one. For a laboratory experiment, a student prepared 500 cm³ of a sodium hydroxide solution with concentration of 1 mole per decimeter cube. So 500 centimeter cube is the volume. Concentration is 1 mole per decimeter cube. The first part of the question, name 2 laboratory glassware required to prepare the above solution. So you all know, students, normally for experiments we need to prepare standard solutions. When we say standard solution, they are solutions with accurately known concentrations. And you all have learned the method of preparing them. You need to calculate the amount of solute. So if it is 500 centimeter cube, 1 mole per decimeter cube, you need to calculate the amount of solute, mass of solute. Then you need to weigh it accurately. To weigh that, you need a watch glass. So watch glass has to be a clean watch glass that you place on a chemical balance. It can be an electronic balance or a triple beam, four beam balance, any of the balances, stable balance. So you use that to weigh the solute accurately. Then you need to transfer the solute from the watch glass to the volumetric flask. So here in this case, it is going to be a 500 centimeter cube volumetric flask. That is also a glassware. To transfer that, you need a funnel. So using the funnel from the watch glass, you transfer the solute into the volumetric flask using the wash bottle. Then you have to make sure that you transfer all the solute into the volumetric flask. So you have to wash the watch glass nicely. Even the funnel has to be washed, and all the solute has to be transferred into the volumetric flask. Then you know, in the volumetric flask there is the volume mark. So you don't fill all the water into that, but you fill about 3/4 of the volume, and then you mix the solution well. So the solute dissolves well in water. After that, you stand it on the table, place it on the table and fill the water up to the volume mass. You have to make sure that the meniscus has to be on the line with the volume mark line, where your eye has to be in the level of that volume line. You know how to measure that. Once you do that, you have the correct volume and correct concentration. There also you need to mix the solution. Then you have to put a label as to what the solution is, when it was prepared, the concentration, composition, the person who prepared it. All the information has to be given in that label. So that is the procedure for preparing a standard solution. Now the question is, name 2 laboratory glassware. So here it has to be glassware. So there are 3 glasswares. You need to write only 2. You need to write 2. I will write all 3. Volumetric flask, then watch glass, and glass funnel. Here, although I mentioned the wash bottle, it is a plastic bottle. So we don't write that under glassware. You can write any 2 of these 3. Volumetric flask, watch glass and glass funnel. And mention it as glass funnel. Is that clear, student? Then, B part, how much is the mass of sodium hydroxide required to prepare the above solution? So we need to calculate the mass of sodium hydroxide. So here you know it is NaOH. The concentration is 1 mole per decimeter cube and the volume is 500 centimeter cube. So to calculate the mass, you all know there are 2 equations. One is the equation for concentration. We can use the symbols. C equals N over V. Concentration equals number of moles of solute divided by the volume of solution. Here we know the concentration. 1 mole per decimeter cube. We don't know the number of moles, but we know the volume. That is 500 centimeter cube. But to convert it to decimeter cube, we multiply it by 1000. So then you will get the answer when you rearrange 1 into 500 divided by 1000. That would be number of moles. So that is going to be 0.5 moles. When you simplify this and this, 2. So when you divide 1 by 2, 0.5. Or you can simplify using the decimals also. 5 divided by 10, 0.5. So either way, you will get the answer as 0.5 moles. That is the number of moles necessary. But here you need to find the mass of sodium hydroxide. To find that, what do you need? You need the molar mass. Here students, I am writing everything in detail. So you can remember molar mass. How do you calculate? You add the relative atomic masses. They are given to you. Hydrogen 1, oxygen 16, sodium 23. So NaOH is 23 plus 16 plus 1. That is 40. But since I have written as molar mass of sodium hydroxide, molar mass has the unit grams per mole. You calculate the relative molecular mass, and when you put the unit grams per mole, you get the molar mass. Molar mass, when you substitute in the equation, you will get the mass in grams. That is why we use molar mass. You can remember that. Mass of 1 mole of substance. So then, to find the mass, if we take that as M, what is the equation? Number of moles equals mass over molar mass. And when you rearrange, mass is equal to number of moles into molar mass. So number of moles we calculated as 0.5 moles into molar mass, 40 grams per mole. Here you will get the value 0.5 into 40, 20 grams. Mole and mole minus 1 gets cancelled off. The answer will be 20 grams. Is that okay, students? So the important thing is you show this equation, or you can write it in words. Find the number of moles, 0.5 moles. Then you need to show the calculation where you find either the relative molecular mass without the unit or molar mass with the unit grams per mole. Then you find the mass by multiplying number of moles by molar mass. Then you will get the answer in grams, 20 grams. That is the mass of solute needed for this particular solution. Is that clear, student? So with that, I'll move on to the next part of the question. So part C. It was experimentally found that the concentration of the solution prepared by the student was a little less than 1 mole per decimeter cube. State 2 errors. So here you have to write 2 errors that would have happened in the preparation of the solution causing that defect. So here they found that although they wanted to prepare 1 mole per decimeter cube, the concentration was found to be little less than that. So if the concentration is less, what is concentration? Moles divided by volume, number of moles of solute divided by the volume of the solution. Either the volume has to increase or the amount of solute has to be less. So the most likely reasons could be that when you transfer the solute, after weighing accurately, when you are transferring the solute, if it is not transferred completely, I told you all have to wash the watch glass completely and you have to wash the funnel so that all the solute has to be transferred. But by chance, if all the solute has not been transferred, then that can lead to an error. Otherwise, when weighing also, now we found the value, the mass as 20 grams. When you weigh, you have to weigh it accurately. If you haven't weighed accurately, if the weighing is incorrect, then also the concentration can be wrong. Another reason, you weigh the substance carefully, 20 grams exactly, and you transfer all the solute. But if the solute has impurities, although it is 20 grams, all 20 grams will not be sodium hydroxide. Then also the solution can have a lower concentration. Is that clear? Now, if the volume increases, if the volume of water that you add, if it is above that volume mark, still you can calculate the correct concentration. But here, if it is these three issues, then the concentration will be less. You cannot do any change because you have already made the solution. So that is what you need to write here. Incorrect weighing of NaOH, or you can say NaOH was not weighed correctly, then all the NaOH was not transferred into the volumetric flask. Or you can say loss of solute during transferring. You can write one of the answers and then presence of impurities in the solute. So you can write any two of these. Actually, they have asked for two errors. So you can either say incorrect weighing of sodium hydroxide, or all of the sodium hydroxide was not transferred into the volumetric flask, or instead of that you can write this: loss of solute during transferring and presence of impurities. So there are three possible reasons or three possible errors. You need to write any two of them. Is that clear, student? So with that, I'll move on to the next part of the question. B part. The following flow chart indicates the manufacturing process of a commonly used polymer P starting from crude oil. So again, chemistry related. So you know what polymers are. Polymers are large chains which are formed from the polymerization of monomers. Monomers are simple units. Normally, they have a double bond or a triple bond. They are unsaturated molecules. Then only those molecules can form new bonds and form a very long chain which contains many number or large number of monomer units, and they form the polymer. That process is known as polymerization. There are natural polymers and artificial polymers. There are even biological polymers like polysaccharides, proteins, nucleic acids, all those are biological polymers. So you're familiar with that. So here it is a polymer P at the end starting from crude oil. So you know what crude oil is, usually petroleum crude oil. They contain a mixture of hydrocarbons. You are familiar with hydrocarbons, carbon and hydrogens, organic compounds. The simple organic compounds that contain only carbon and hydrogen, hydrocarbons. So hydrocarbons can have just one carbon atom, methane, CH4. The number can increase. They can have very high number of carbon atoms. They can be hydrocarbons. So starting from crude oil, then there is a process A taking place that gives rise to naphtha. Naphtha is a chemical substance that is actually produced. It is a product of fractional distillation. You can remember the fractional distillation tower, fractionating tower, where naphtha comes out as a chemical substance. It is used to manufacture different other chemical substances. So naphtha is something you're familiar with. Then from naphtha, there is a chemical synthesis that gives rise to ethene. Ethene is a hydrocarbon. C2H4, it is an alkene. You all can remember ethene has a double bond. C2H4, there is double bond. So ethene can polymerize. So here you can see polymerization and form polythene. Polyethene is polythene. Ethene is also called as ethylene. So polythene, polyethylene or polyethene. that is polymer P. So you all have understood the process. Crude oil, fractional distillation, you can get naphtha, undergoes chemical synthesis, you get ethene, then ethene polymerizes to form P, that is polythene. Is that clear? So then, if we answer the questions, first part A, the letter A indicates a separating technique. Name that technique. So I said fractional distillation, that is a separation technique. You all know, students, distillation, you have a mixture that is converted to the vapor state and it is condensed so that you get the liquids or solid, gas, liquid, solid all separated out. But the process, one thing, it has to be converted to vapor and then condensing. That is distillation. But here we take different fractions out at different boiling point values. That is why it is known as fractional distillation. It is a separation technique. So that is what you need to write here. Fractional distillation. Fractional distillation. Fractional distillation technique. Is that clear? Separation technique. Then B part, state a solid component that can be separated from crude oil using the technique you mentioned in A above. Now you can remember, students, if you take the fractionating tower, at the bottom, the components that have very high boiling point are removed. Usually, it is in the solid form. You can remember bitumen or tar that is used to make roads. That comes out from the bottom. Then we have wax. Wax is also a solid component that also comes out from towards the bottom. So, those are solids. Then in between, as you go up, you have the different liquid components, even naphtha, kerosene, diesel, petrol, all those are in between. Those are all liquid substances. Then after that, above you have the biogas methane CH4 coming out, and LP gas, liquid petroleum gas, which has propane and butane. They are coming out in the form of gases. They have very low boiling points. So they come out from the top below 25 degrees Celsius. That is why they are gases at room temperature. So methane, ethane, propane, butane. Propane and butane are the main components of LP gas. So those are the components. Here the question is, state a solid component. Solid component. So like I said, it can be bitumen, or tar, or else wax. So those are the solid components. Here it says a solid component, so you can write any one of the answers. Is that clear, student? So with that, I will move on to the next part. Again, the same diagram. Second one, draw the structural formula of the ethene molecule. So when we say ethene, eth refers to two carbons. You all are familiar with the naming system. Ene means there is double bond. And also there you can say C2H4. So there are two carbons like that, and there are only 4 hydrogens. So obviously when these hydrogens bond like this, carbon valency 4, there are only 2 bonds. So there is a double bond between the 2 carbons. Anyway, you are familiar with this structure. It is the monomer for polythene. 2 carbons, there is a double bond, and 2 CH bonds here. So a CH bond, another CH bond. So there are 2 hydrogens on each carbon. That is the structural formula of the ethene molecule. So structural formula means this is the structure, how the atoms are bonded in a particular molecule. Is that clear? C2H4 is the molecular formula. One molecule has 2 carbons and 4 hydrogens. This is the structure. So structural formula of ethene molecule. Is that clear? If they ask you for dot cross, Lewis dot cross or dot diagram, that's a different thing. Here it is the structural formula. You show the bonds using lines. Is that clear? So then the next part, that is part 3, name the polymer indicated by the letter P. So we already discussed that it is polythene. So you can write it as polythene, or you can write it as polyethylene, ethene, or you can even write it as polyethylene. Polyethylene. Polythene, polyethylene or polyethylene. One of the answers can be written. Is that clear, student? So with that, I'll move on to the next part. That is part 4. Ethene can be polymerized, but ethane cannot be polymerized. What is the reason for this? Now you can remember, students, ethene is C2H4, ethene. That we wrote the structure has a double bond like that. Whereas ethane is C2H6, ethane. Ethane, you know, they are alkanes. Alkanes are saturated molecules. They only have single bonds. So if you look at the structure, it is like this. Like that. So there are no double bonds. Only if there are double bonds. Now this is something I am giving you the explanation, students. You don't need to write this for the answer, just for you all to understand. If you have like that, the ethene molecule, another ethene molecule, what will happen? When they form bonds, this bond breaks and forms a bond here. This breaks and forms a bond with the next molecule. So like that, you will get a long chain. So this will give rise to the formation of C like this, a long chain. Like that. So you can form bonds there. This would be the end of the chain, but in between you will get this will be the repeating unit. Now this is not the exact way to write. I am just saying this is the component that will repeat. Now this is possible because of this double bond. That is not present in ethane. So ethene can be polymerized, but ethane cannot be polymerized. What is the reason for this? Ethane does not have double bonds. So here the answer is, here you have to give, you can say ethane has only single bonds. I can say ethane does not have double bonds. So that is the reason. It doesn't have double bonds. It only has single bonds. Because of that, it cannot polymerize. Ethane has only single bonds. So it cannot polymerize. Is that clear, student? So this is for you all to understand how polymerization takes place. But this is the answer. Is that okay? So then I'll move on to the next part of the question. Part 5. The equation relevant to the complete combustion of ethene is given below. So here C2H4 gas, ethene is a gas, plus 3 O2 gas. So there are oxygen gas, there are 3 O2 gas. They react and form 2 CO2 gas plus X H2O liquid plus heat. So when these two react, ethene and oxygen react, you get the products 2 carbon dioxide gas and X H2O liquid plus heat. So there they haven't given the number of water molecules, it is given as X and it is in the form of liquid plus heat is released. So that is the equation. First question, A part. What is the value relevant to X in the above equation? So you all know how to balance chemical equations. Here you can see, if we look at the reaction, C2H4 gas, ethene gas plus 3O2 gas, but there are 2 CO2 gas molecules as the product and H2O. Now here you can see carbon C2, there are 2 CO2, carbon is balanced. There is 4 hydrogen atoms in ethene. So those 4 hydrogen atoms should be present in water. Water is H2O. So you need to have 2 water molecules. So X has to be 2. So when you have 2 H2O, if you count the number of oxygen atoms, 2 into 2 O2 means 2 into 2, 4 oxygen atoms. Here 2 oxygen atoms, altogether 6 oxygen atoms. That is why you have 3 O2 gas. Is that clear? So X, the value will be 2. So if you write the answer, what is the value relevant to X in the above equation? It is 2. Is that clear? Then the B part, sketch the energy level diagram relevant to the complete combustion of ethene, indicating the levels where the reactants and products exit. So here you can see heat is released during the reaction. And normally you all know combustion is an exothermic reaction. So that means the energy of reactants is high, energy of products is low. So when the reaction proceeds, heat is released to the environment. So that is how combustion happens. Exothermic reaction. So you have to show that in an energy level diagram. So if you draw the energy level diagram, it's going to be like this. Here. So this will be energy. And normally energy is in kilojoules per mole. You can remember that. So you have to give the unit as well. Then you know you have to write the reactants and products in the relevant energy levels. Here, since it is the exothermic reaction, reactants are on top. So we need to have C2H4 and you have to write the physical state. You all know heat changes or energy changes are related to physical states as well. So it is compulsory or it is a must to show that as well. C2H4 gas plus 3O2 gas. So here it is only 1 molecule of C2H4. There are 3 molecules of oxygen gas. Then the products are going to be 2 CO2 gas plus 2 H2O liquid. Here in the equation we have H2O liquid and we have balanced it. There are 2 water molecules. And then we show the arrow. So here energy is released. So you can show that as well. Energy released, or you can say heat released. Heat evolved. So energy is released during the reaction. You have to draw the axis. You have to label it as energy, the unit kilojoules per mole. You have to write the reactants, the products. Since it's an exothermic reaction, heat is being released, so energy release. Reactants have high energy, the higher energy level, and products are at the lower energy level. And you need to write the physical states as well. Is that okay, student? So then you get the complete marks. And here it is mentioned as 20 marks because the full question, this is question number 6, that is marked out of 20. All part A and part B, all the questions together is out of 20 marks. Is that clear? So with that, students, I am going to end this chapter, and in the next chapter, I will start discussing the question number 7 of paper 2, part B.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.